Hey guys, this is Tim, back again with another video. And you might have seen my short little R&D project called Convergent. So this is a tutorial about how that was made. You can get the HIP file as well. If you go to my Patreon, you can download it there. So that's patreon.com/timvanelsding, and you can look through the entire project file. You can easily resim it with running this. And you can look through how everything was done. But this video is going to give an overview of how all of the elements were made, how I used one of my own tools called DopInstancer to do the cool dynamic stuff. And yeah, without further ado, let's dive into how some of the stuff was made. And I think there's a lot of cool tips and tricks in here that might help you improve your Houdini skills. So let's dive right in. So I actually made this a while ago, just when I was playing around with one of my own tools that I made called DopInstancer. And by now Houdini 18 is out, so it's kind of sort of redundant, not completely. But what it does is, I have a video here, it allows you to instance objects into DOPs and create constraints dynamically like this. So some of this stuff is now also in Houdini 18, but like this was a quick thing that I did as a test for that, and I ended up rolling it into just rendering it out because I thought the effect looked cool. So what it can actually also do is dynamically create constraints, like you see here. So it's dynamically creating spring constraints. You can also create other types of constraints. If you want to know more about this entire thing, there's a full tutorial on how the DopInstancer works on my Patreon. So I'm not gonna dive too deep into that because there's a big tutorial on it already. So head over to Patreon if you want to see that. But I will show you how it was done. And again, in order to do this, you need the DopInstancer. So let's dive into the DOP network here and see how that was set up. So if we dive into the rigid bodies, and it's already gonna start to cook a little bit, and if I play, you can see there are some boxes being emitted. So as you can see, this is the way this is set up. I guess I can delete this one. So it's a packed object here, and then it's set up to use the instance to use the instancing. So this is the instancer itself, and as you can see, I emit a box over here. There's 3 variations, but for now I'm only emitting one, and I'm replacing them after the simulation. So in this thing, you can basically just say, okay, I want to emit a certain object. So you can select an object here to emit. I could also emit another object if I wanted to. Can be from object level or from something else. And then I am setting with some vex, some random stuff. So I can so their orientation is random from the beginning. So I'm setting the normal to be equal to what I'm setting here. It's just some vex, and I'm setting some random p scales for them. So that happens based on the ID. And DopInstancer creates IDs and stuff, so you can use IDs that way. So yeah, I mean, I'm not gonna go too deep into the vex stuff, but basically the p scale here will call a fit function based on this. So it will create a random number based on the ID, which will be between 0 and 1, and then it will fit it between 0.25 and 0.7. So it will just create a random p scale based on the ID. So it calls more random functions in here, and so this is just basically setting a random normal. And inside the DopInstancer, this will all be converted to other stuff that the DopInstancer can use. But you can just easily do stuff in there. So I'm just saying options to instance in here. So that's the one box. And then there's also the emitter. So you can emit from multiple different things. Like for example, if I'm emitting from a custom shape now. So if I show my second view, you can see there's an emit shape. So the emit shape, this is what I'm emitting from basically. So if I'm gonna play on the left here, maybe show object, you can see there they get spawned inside of the torus. But I mean, I could put another shape in there if I wanted to. I could also just disable custom shape, and then it does it just inside the sphere by default. And you can set the emission rate over there. Like you can also instance, like instead of instancing this, you can also instance from disk and doing other stuff. But again, like look into the DOP instancer tutorial to see how that works. So basically this emits all of these boxes, but it doesn't create the constraints by default. That's done with the dynamic constraint. So if I disable this, it still shows it. I guess I need to completely disconnect it for it to stop cooking. Yeah, so let me hide some of my stuff. So now you can see they get only they only get attracted together. They don't really so they do get attracted together, and that's because there is a pop attract here. So the pop attract will just attract it to wherever that thing is located. So that's just being attracted to the center here. So nothing too fancy. But the dynamic constraints will create the constraints. As you can see, if I turn it on, you can see constraints appearing. So that's where a lot of the cool stuff happens. So inside of this thing, just set a very basic spring constraint. So you can see, so it's gonna look in a radius. So basically what that's doing is that for every box, it's gonna look, okay, like in around the radius, and if it finds another box, it will add a connection, and I can say the maximum connections as well. So if I like were to lower the search radius by a lot, and you can see it's not really that much happening until they get super close. I could like make it super high if I wanted to, and then if I play, you can see they instantly start all being drawn together. I could only give it a maximum of 2 connections, and then if I play, you can see it can only connect to 2 other parts. So you can play around with this. You can also create other types of constraints, and then in the bottom here, it's just basically creating a constraint network. You could also randomize this and create other types of constraints. So there's run over points. So if you want to do point stuff on the constraints, you can do that here. And run over prims will run over the primitives. So this will do some random functions. So again, I'm calling float r, which will open a variable called r. It will be the random based on the ID. Then I'm fitting this between 1 and 5. So it's just so we have a random based on our r. Am I even using it somewhere? I guess I didn't even use the r. Again, when I was playing around with it, I was just trying out certain stuff. So the rest length will shrink over time. So the rest length is the length of every constraint. So if you have so basically the length of this line will be measured, and that's the rest length. So what it will do is every frame it will shorten it, because it will multiply by 0.9. So that will mean it will shorten by 10% every frame. So that's why they all get like drawn together. Then it gets clamped. Same for the strength, so the strength of the constraints. And then I have another wrangle here. So if it's above frame 245, that they will be removed, and that's because if we keep playing, they explode outwards at the end. So let's keep playing, and there we go. So then it will remove the constraints at the end, because if I didn't do that, then they would, I mean, we can have a look at what it does. Because I wanted to have the explosion at the end, right? So you can see we're gonna wait for this to happen. So they do blast out, but they keep but they sort of keep the connection. So we don't really want that. So other than that, it's a pretty basic constraint network. So constraint. So if you don't know how constraints work, there's a lot of other stuff going over that. But basically, it will say, okay, this is a constraint network over here, and in over here you can plug stuff like subsolvers, and this is made with a subsolver, so that's why it is. So normally you would like load in your constraints over here that you made, for example, in subs. But right now we're generating them on top level, so that's where we plug it in here. And then we can say what type of constraints do we want. So in this case, we want spring constraints, because again, that's what we set this to be. So this is constraint name is spring. Yeah, pretty straightforward. So that's what's creating the dynamic constraints. If you want, you can dive into this and see how this works. But again, like if you watch the DOP instancer tutorial, there's a lot more on that, and these are all editable. So they're not black boxed, so you can just. So apart from that, it's just some generic pop forces. So if the age is greater than, because this also ages stuff, so because we need an age attribute, so we can use that. So if the age is greater than 0.5, the amplitude will be 0. Some other stuff like limiting the speed a little bit, adding some drag. What am I doing here? So if the length of the spin, so if the W means the spinning velocity. So basically what I'm doing here is saying that I'm looking for the length of the vector. So basically the intensity of the vector. And then if the length of that is higher than the max, then it's gonna severely slow them down. Let's say if I didn't do that, let's see what it looks like. Maybe it doesn't make that big of a difference in here, but again, there's still some, so it doesn't make that big of a difference right now. But I was playing around with this when I was making it, of course. And there were some weird stuff going on. So let's see. So if we go into the subsolver here, this is basically what this does. Is if they get super close, you can see it very mildly, but they start having a sort of a mild red glow. It's not that obvious, but I can increase it if I want. So if I increase this value, you can see it better. So let's first play through it and see what happens there. So you can see once they start connecting, they start turning red. So basically what it was, I wanted it to sort of light up when they would like get close, so have a tiny bit of emission going on. It's not that visible in the final video, but it is there. So let's make it a little bit lower like it was. So basically how that works is just saying like the max neighbors for the for the point cloud. So what we're gonna do is we're gonna do a point cloud. For every point we're gonna look around, like how far around can you look. So it's the radius, and so we're gonna say an integer the neighbor count. So how many did you find? So PC number found. So how many did you find? And if it's above 0, then they will be grouped. So if you find more than 0, so if it has one neighbor in this range, then we're gonna do this thing. So this thing basically grows the attribute called grow by 0.001 every frame, and this is just adding the color so we can visualize it. So yeah, this is later used in the shader, so that's pretty pretty standard. So in the other wrangle, so if the frame is above 243, and then again, like later we're exploding the whole thing, so we want to like have them not glow as much maybe after they explode. So then the grow attribute will shrink by 10% every frame. And then if grow is below 0, then grow is 0. So I'm not sure why I added that, but it's there. So basically that's the whole DOP network. So it's pretty straightforward in terms of how it works with the instancer. Of course, the instancer itself is a little complicated. I'm not going to go over how that works because you can see it's like quite a big thing. If you want to know more about the DOP instancer, you can watch that tutorial on Patreon. So yeah, anyway, so this is the simulation, and now we can load this simulation and then do other cool stuff with it. So again, you can run the whole sim by just running this. So this is a ROP network. If I dive into here, you can see it fetches all kinds of simulations in here and it will just run it. So it will run all of these nodes. So yeah, then when you run it, you end up with something like this. If we look in the first string, so let's play. And you can see them lighting up, like getting a little bit red. So that's the basic simulation stuff. So now let's dive into some other stuff that I did. Right, so just some simple things. Like there's an attribute VOP in here, and if I dive in here, you can see some stuff going on. So what it does, so I freeze one of the frames here. So I freeze like the last little frame here, which is like just before it explodes. And why I'm doing that is basically I have a little noise here that sort of, yeah, just offsets them. So I'm doing this to create sort of a jitter effect. So when they, if you go close, you can see it a little bit better. So if you play, you can sort of see them like jiggle a bit more. And I decided to not do that in the simulation, but just do it post simulation. So I just have some more control over here. So let me dive into how that works. So what I'm doing is I'm importing the position of the second input. So again, the position, because they're the same amount of points by the time we start doing this. So this works perfectly fine. So I'm importing this position of the frozen stuff. So it's our rest position basically. I'm sampling that into a turbulent noise. Then I'm just put the time in the offset. So it will just add time to the offset. And then I'm having a multiplier. So that will like say the amount of the speed. It will also get multiplied by the grow attribute. So it will only happen if they have the grow attribute on it. And remember, the grow attribute is the red color. So the stuff that we grew when they started getting close, it would start accumulating the grow attribute, and the grow attribute, we're multiplying this in here. So that's just doing that. So importing rest position, sampling that in the noise. Then we're adding the noise to our position. So what this will do is we have the points all have a position, and then we have a noise, and we add the position of the noise to the other thing. It will just offset them. Basically is what it's doing. And the amount they get offset, so we have will be controlled by our amplitude and with our grow. So let's dive into it. So like let's say if I time shift this thing as well, so maybe then we can maybe see a little bit better what happens. So let's look at this thing. If I play this, you can see the boxes here in the center are sort of just wiggling around. The boxes here are not really wiggling around that much because they don't have that much of the grow amplitude, the grow attribute, remember? So if I increase this, you can see stuff in the center there goes absolutely crazy, and these other ones do it a little bit. That's because the time is multiplied by, so the time is this one here. Maybe I should call it time so it's easier for you guys to see as well. Let's call it time. So I'm just multiplying the time, so it's just how much they get offset basically. I kind of want to keep my keyframes on it, so let me undo some of that stuff. Okay, so for some reason it removes the keyframes when I rename this. So let's just keep it as input number 3. But remember, this is just the time. Let me just change the naming here as just the time, just for the label, and it should work. All right. So that's all. That's working fine. So yeah, underneath that, I'm just doing a time blend. So this is just so it can interpolate between stuff when you're doing a time shift. I'm not really doing that much in the time shift here, I think. But time blend will allow it to interpolate subframes. So if you're doing retiming, for example, it might be useful. Then I have this thing over here. So if you can look at this wrangle here. So let me see how it's set up. So it does random based on the ID, clear enough. Then I'm fitting the random between 0.5 and 1, clear enough as well. So fit at age. Okay, so what I'm doing is I'm shrinking them down based on the age. So what I'm doing here is I have R, and I'm saying R, so float R should fit the age. So the age of how old are our particles between 0 and our random value, and then put that between 0 and 1, and then I'm dividing my p-scale by it, and then I'm doing a multiplier thing as well. So what that is basically doing is, like, I have this slider, let me go in here. So you can see they will sort of randomly shrink down a little bit, and again, like, I have this control here. So that's just when they explode that we have some control over that they should get smaller. And again, they're still there, they're just so small that you don't see them. Yeah, I'm just offsetting the stuff by 10 frames here because I guess that looked better. And then I'm computing with a trill. You can compute velocity because we need that for the motion blur. So we're doing that. So yeah, that's our little rigid body sim here. Right, so you might notice this other thing here on the left, where I'm sort of creating a volume from the boxes. You're like, why are we doing that? Because there's not really any volumetrics in here. Well, I mean, there's volumetrics. There's like light going through it, but there's no not smoke emitting that much from it. But there's like particles, and the way you can get like super cool, smooth, wavily particles is by advecting them by an actual smoke simulation. It's also what I did with the, if you saw the Spirit of Autumn, there's like the leaves are swooping up really nicely. It's also done like that. If you want to see the tutorial on that, that's on my Patreon. If you subscribe, like and subscribe, etc. But over here, we're just using it to get super nice swirly movements, which you can, for example, if you look over there, you can see some swirly stuff going on. You can see they get sucked in a little bit at the end. So yeah, we're just like setting up a density attribute here. So the density is 1, and then the density is divided by age. So it will decrease with the age. And if so it will increase with the age. And then if the density is above 5, then the density is 5. So let's see what it looks like. The visualizer here. So it will decrease over time. And also, maybe if I turn it up the density a little bit, it might be a little bit easier to see. So it's just a simple simple volume stuff, and we can use this inside of a Pyro simulation to get some velocity going, and then we're going to use the velocity to drive our particles. Right, so I moved up a level, and let's dive into our Pyro here. So this is a super simple Pyro sim. So let's play through it. And this sim's super fast because we don't really need a lot of detail for this. We only need the velocity stuff. So you can see it's emitting stuff from the boxes. And it's also taking up the, so it's gonna, if I look in here, it's also taking up the velocity. So let's go into the already know. So this volume rasterize attributes, what it does, it takes attributes. So we set up a density attribute. We also have a velocity attribute. So this will basically create a VDB. So you can see it create two VDBs called V and called density. So So it will take the velocity and source it from the velocity that was on our boxes. Not sure why it's not visualizing. Do we have it here? Let's see. Always use your geometry spreadsheet kit. It's important. For some reason not visualizing here, but you can see we got velocity going on there. We're making that into a velocity volume. So maybe if we want to visualize what that's doing, we could say that we want to scatter some points, for example, inside that one. And then we can use volume trail. So we can say point to trail, like which points do we want to trail, and then we want to like which velocity volumes do we want to use, and it's called V in this case. Now you can see we get these nice little trails that basically represent the way that our boxes are moving. And again, we can remove this again now. But then if we go into the Pyro simulation, so this will source it. This will basically say, okay, we're sourcing density to the target field density. But another thing is like if we have a vector, because velocity is a vector, remember, it's not a float, it's 3 floats, it's a vector. So it's gonna source the volume called V, and it's gonna source it into vel. So vel is the velocity, and it's gonna add it into it. So then we get a nice little sort of Pyro sim. So this will create nice swirly movement. And apart from that, there's not really a lot going on. I mean, I'm dissipating the stuff a little bit, and I think this is all set up with like just default stuff. I'm not sure, or not even doing much with turbulence at all. Just a just a very simple setup. All right, so then if we dive into our PopSim thing here, let's is this set to load? Yeah, it's set to load. So you can see this is our simulation here. So maybe if we move our camera a little bit, you can see it's not really that interesting. Maybe we can make the background dark. Again, like if you press D, you get this thing and you can go to background and you can put it to dark. So you can see we're getting this sort of wispy, smoky stuff. Again, we're not really rendering this specifically, but we're using it to advert particle simulation. So that's how we get this very natural looking sort of swirly motion of the particles, which is a lot better than if you would just use pop forces. Okay, so how can we use this inside of a pop simulation? Oh, good that you asked. We have this, so I just made this box. This basically contains our entire scene. Basically big enough for an entire scene. We're just making it into VDB from polygons. So what I'm doing there is I'm scattering some points. And I'm only gonna source these once. So I made 75,000 points. So these are here. And then if we go into the pop network, you can see there's a source here, and it's just saying that impulse activation $f equals 1. That means it will only emit on the first frame. Then I have a regular pop force, which just, so if I just select this, so they will just sort of like move a little bit from the beginning. Can we turn off the guide for this? Yeah, so they will just move a little bit in the beginning, because in the beginning there's not really any velocity from the Pyro stuff, of course. So we do want them to sort of move from the beginning already. So if we go over here, you see they're already moving in the beginning. But again, if I play this, it's not like super interesting. It's like very boring particle movement. Let me turn off my origin with no one. But we have a pop advect by volumes in here. So this is where the magic happens basically. So I'm putting in the velocity from our thing. So that's the thing we made here. So I'm putting this in here. The field we want to load is vel, so the velocity. I just upped the scale a little bit. And there's multiple ways to advect it. So I'm setting it to update the position. So instead of like pushing on it as a force, just move along with it. So if I play this right now, you can see, if I play, you can see stuff starting to happen. So that's where the boxes will happen. It will, let me get rid of the camera. you can see particles will start moving and get the super cool swirly motion. And it's really just updating the position instead of using it as a force. Like if I were to put it as a force, you can also put it as a force if you want, but then it's gonna like push on it, and then it's gonna get more of this explosive sort of look, which might be cool in like other things, but I thought the other thing looked better. You can also set it to update velocity directly, so I can, if I play this, and we'll update velocity directly. But again, then they will fall still in the beginning because it will just negate the velocity that's already there. But in my case, I liked how update position looked. So this is a super basic stuff for the particles, but it ends up looking super cool if you render it properly. So another thing that I did in here in the SOP solver, which I even forgot that I did, is I'm also loading the points from the boxes. And I'm doing another point count lookup in here. So again, the point count lookup this time in VOPs will say, okay, I'm going to look at the input from the second input. So that's going to be, this is going to be the second input. And this is going to, and the first input is going to be our simulation. And then it's going to filter over the grow attribute because these points have the grow attribute, of course. And then we're going to bind grow. I'm going to add it to grow and then output it to grow. So again, if they get close, if the points get close to the boxes, it will also, they will also start picking up the grow attribute, and then it will sort of start emitting more light. I'm not sure if it's visible in here, but it's in there. Yeah, that's basically the particle simulation. So we just move through it. That's it. And particle simulations never really look that great if you just see them unrendered without anything else going on. Sometimes it might be like it's really difficult always to sort of judge what a particle sim is doing. If you want to have a better view of sort of what your movement is doing, sometimes it's a good idea to do a trail. So let me put down a trail, and then I can trail the points. Let's just increase it. You can already see it. And if you then put add and put it to by group and set it to ID. Now you can see we get a little bit better of a view of like what our points are doing. You can see like where the boxes start to appear. Maybe I can show the boxes. Why is it? No, I don't want to do that. So you can see, now you can really see the movement like going around the boxes that way, and it actually looks kind of cool like this anyway, with just the let's dive into there, with just the lines. So you could actually, I guess, render this and have like a pretty cool thing going on. So yeah, I guess that could be a cool motion design type of effect, but it's good for visualization as well. So yeah, let's go into there. So here I'm just saying some random p-scale values by sliders with some vax. And then what I'm doing here, let's see. Yeah, so you can see I'm tinting them with the grow attribute. So you can see when they get close, they get sort of more orangey. Let's see if that's even visible. I'm not sure. You can see a little bit. You can see some orange particles coming over there. Not sure what I'm doing here with the multi-attribute. I don't think I'm even using that. Maybe I'm using it later. I made this 2 months ago, so could be overlooking a couple of things. So yeah, in this wrangle float length, so the length of the velocity, and then just writing that out as a len attribute. We can use that later in the shader, and just setting that alpha is 1 because I'm using alpha in the shader, and if you don't specify it, it will evaluate to 0 and then it will just be invisible. So if you're using a shader with something with alpha in it, just remember to evaluate, like to put it to a value of something on everything that you're rendering. All right, now it's time for a little intermission, sort of. So let's have a look at how the boxes themselves were made, because obviously they're not like, they have some stuff going on there, and actually it's not really visible here. Actually the pattern on these animates, but because there's so much going on, you don't really see it that much. But we can go over how I did that. So if we go to the Redshift render view and let's render our box, so we can actually have a look at one of our boxes. So it should work. All right, so you can see this is one of our boxes. So if I actually scrub through it, you can see that actually the displacement pattern moves across the box. You can see, so it's sort of it's actually pretty cool. Like if I were to increase the displacement, then oh, I have a random displacement. I have a displacement control here. Oh well, let's just override it for now. Let's just say whatever, plus 0.2 or whatever. Let's see if it makes any difference. Okay, now it's gonna break. Is it gonna break? Oh, okay, it doesn't make that much of a difference. Anyway, so these were actually these patterns are created sort of procedurally on the fly. Well, not completely procedurally, but sort of procedurally. So let me show you a cool trick how I did that. So they're actually, like if we look into the shader, so material, so let's fast forward a little bit to the shader. So we go into the boxes, and you can see if we look in the, with Control B, by the way, you can maximize something like this. You can see if we look at the texture sampler that's going into this displacement, it's set to, not set to a texture, but set to OP, and then in the image network, height. Okay, so let's dive into there and see what it's actually pointing to. That looks interesting. So let's go there. So you can see image network, and then we can go to our composite view actually and then have a look at what this is. So this is what we're using for displacement. But again, this is not an image sequence. This is something I'm generating procedurally inside of Houdini. So let's see what it does. Okay, so this refers to /obj/displays output. So let's go in there. So that's this thing. All right. So actually, if you look in here, this is actually what it's using to generate the displacement. So let's see how this is made. So it's basically, we have a grid here, super long grid actually. So scattering points on it, sending some random stuff like random scale. So p scale is global scale, and then you can individually scale stuff with at scale.x, y, z, etc. And then if you copy the points to it, you can see I have some boxes going on, and these are moving. And why are they moving? That's because of the stuff going on here. So it's saying creating a random, so float R, random based on the point number. So it's creating a random value between 0 and 1 based on the point number. So point numbers. And then it's gonna add the random value to the p.z multiplied by the slider that I have here. So this just basically moves them sort of randomly like this. And then if I copy like the boxes to it, it will take up the p scale and the other stuff, and then just move it like this. And then what am I doing here? I'm scaling them down a little bit. As you can see, we're doing this because they were like a little bit too big before we scaled them down. We wanted them to be a little bit less high. I guess we could have also done it in a wrangle, whatever. Yeah, so giving them color here, but not really using it, I think. So giving color to the grid, and then we have a height field here. So we just make a height field. So it's just going to be a small height field by 10 by 10. Make sure you have enough grids, like a low enough grid space, so we actually have some resolution. So my resolution is 1000 by 1000. And then we can use height field project, and height field project will basically project your height field on a geometry. So combine method, I have it multiply. I can also set it to add, but I wanted to set it to multiply so it stays at the bottom. And then, and that one is going to go into the height here. So you can say, okay, what resolution do we want? So we're just taking that up basically, and that's gonna extract the height field information. And then if you use it with OP double dot and then point it towards, it will evaluate during render time. So then we can create super cool animated displacement effects. So like it's not super visible in this thing that actually happened, but I thought it was like pretty cool trick. So that's a thing that I did. Yeah, so then I basically have a couple of different boxes here. So I just emitted it based on one box, but like I wanted them to swap out later. So I just have a box here, which doesn't have UV. Should have UV. Where is it? Yeah, so we have a UV thing going on there. So UV. And I'm just like randomly rotating that one a little bit. On the other box, I'm rotating it a little bit differently, and I think I might have done some other things, but just generating three different boxes. And then if we go to the place where we render our boxes, so this is an instancer, so instance. And I have other tutorials on instancing going more in depth as well, but what I'm doing here is I'm merging in these points. So let's go to render cam. So I'm merging the points in, and a little bit dark, but I'm merging these in. I'm adding another point, because if the instancer cannot find anything during render time, then it will just put them in the center, and we don't want a box in the center. So I'm just adding a point which is like randomly somewhere, and then it'll render a box like way out in the distance. That's why I just have an add there. Then I'm putting an add here to set to delete geometry, keep the points. So then it will delete everything, but only keep the points. So yeah, I'm saying random instance. So this will write out an instance attribute. So I can say the number of instances. So how many instances do I want? 3. So this is just an integer. Then I'm saying that the instance attribute should be this plus this value. So if we look at the instance over here, let's look. You can see I get an attribute. I got 1, 2, 3, 4, whatever. If I up it, you can see it will do it more often. And I'm also randomizing the p scale again a little bit. And then in here I'm calculating the length from the velocity and fitting it between 0 and 1. So we can use it in the shader. And yeah, then we have our boxes here. Again, so it's replacing these instances. So if I were to make this thing a pig, then you can see there's a couple of pig boxes right now. So that allows you to sort of swap them out afterwards. So that's quite nice. Right, so one more effect that's in here, and it's before you move on to rendering, it's electricity. I have another tutorial based on how, like, more in depth on how electricity is done, but we can have a look on basically what it looks like and sort of roughly what it does. So let's see. So we have this box here and the points, and I'm just copying these boxes to it. Let me turn off my do it light background. Right. copying that, and then I'm copying those unpacked, so just a box, copying them, because again we were randomizing the p scales again here, so they need to match up. That's why I'm doing it like this and not loading in the other stuff. And I'm scattering points on it, and I'm scattering other points in here as well, based on the same density but just with a different seed. So then I'm saying add ID is point number plus 1. I'm doing the same there, and I'm just merging them together. I'm just putting an add, and I'm adding them based on the ID, and just adds. So it will add the randomized. So if I add them together, so if I change the seed, you can see the way they get added changes. Then I'm measuring the length of them, measure parameter and putting to len. And then in this one, I'm saying if the length is greater than whatever is in here, we can remove them. Promoting ID from point to primitive. And then I'm doing remove prim, so I can have some control over like how many electricity points do I want. Just doing it in here. Then I'm resampling all of these, because right by default, right now over here, they only have 2, and then I'm resampling them to have some more. Then I'm putting UV texture from arc length to spline, so that will create a UV attribute on the lines for every line. And the UV.0, the first component, will be 0 to 1 for every line. And then in the attribute VOB, we can use a vector to float and take the first component and then ramp that, and then multiply the amplitude of the noise, and then add the noise to the position. So that what that will basically do is just like it will so this will allow us to offset the position of the thing based on the ramp that we have here, and it will multiply it by the noise. But because we have the ramp, and from the UV attribute, the ends will always stick to the boxes. And then I'm doing another resample, and I'm doing another one of those, but like with some smaller details, and I'm doing another resample, and I'm doing another one with like even smaller details. Yeah, so I also I have using flow noise in here, so time in the flow noise, and that will sort of create a flowy type movement. So if I freeze this, maybe we can see it. So you can see if we like look through it, that's because of the flow, and then the flow rate will basically say how fast will it do this. Okay, I guess it does a little bit. So again, I'm doing that everywhere, so it will get a nice flowy movement everywhere. And I'm also creating a width attribute. And then, so I'm doing the width from the UV. So thin at the edges and then thicker in the center. And then I'm multiplying the attribute with a noise. And then if you put in like a poly wire, you can see we get this this nice sort of randomized look. So that's in here. And we kind of want to fit it to a minimum, because if you put it to 0, then some stuff will just disappear because it's infinitely thin. You can just play around with that, and I'm just adding a color here, I guess, for visualization. So yeah, that's how the electricity was done. The electricity was actually rendered separately and then comped on top of it. But yeah, so that's basically all of the dynamic stuff out of the way. So with that out of the way, I guess we can go into some of the rendering. All right, so if we go to the box material, and I just noticed I had the wrong material applied to the boxes before. Not for the final render, but so there's actually not that much going on. It's just very basic material. But there's a lot of stuff that I'm doing for some custom AOVs. So like, let's dive into the node network. So I'm looking up a lot of attributes called the grow attribute. So that's the attribute that we can use to light stuff up, for example. Let's see, what else am I looking up? Grow attribute here, the len attribute, the UV attribute. So all kinds of attributes that we can later use in compositing. So if we look into, for example, After Effects, composite, for example, here's the curvature attribute that we wrote out, and over here you can see it's a little bit dark, but so this is what, when we look into the shader, it's gonna compute curvature by the grow, so it's gonna have more intense curvature based on the grow attribute. So if you look in here, so where they are more together, this thing will be brighter, and what this is then in turn used for is in the composite. We can use this to to crank up, for example, the exposure of the light. So let's say if I put this to like 20, let's wait for it to do something. Wait, it's turned off right now, so let me turn it on. Let's turn this off. Let's turn this on. Yeah, now you can see it. So it's basically, it's gonna sort of turn up the exposure of the stuff over there, so we can get this nice light up type of effect. Same we're doing with the with like some of the other stuff. So we also have the have this pass. This is the grow. It's the grow attribute you can also use, and I have to look a little bit through my composite to see where I'm using what. But let's just show some stuff and what it's actually doing. So again, like this is our grow attribute here, and I didn't even use it that much, to be honest. But you can see if I turn it up, for example, we can have this control over where they would like glow up a little bit more. So I'm just using a lot of custom attributes here, and apart from that, it's very basic material. So just writing out a lot of passes. So how you do that is you can put scalar is going to be 0, like black and white, so float values, and color is going to be color values. So for example, our UV attribute, I don't think I ended up using it, but I could have. So you just store them by plugging attributes in there, and then just giving them names, like what do you want them to be called, like that. I guess I forgot to put the UV, but I didn't end up using it in the render, I think, anyway. So if you then go to your AUV, and I really love this little thing you can plug in there. I actually suggested that on the forums, and I put it in like super quick, so it was really cool. So props to the developers there. But you can make custom AUVs here, so you can, as you can see, you can create custom and then put in the name, and then it will write it out as a custom attribute. So let's say if we were to go back to our main render and then wait for it to start doing things, and it's going to be quite slow, but if we can, let's say if we go to curvature, right now it's not going to show that much. Maybe if we just turn off depth of field. You can see, yeah, you can see it appearing over there. And the particles look horrible without depth of field. So yeah, that's how I used custom AUVs for that. And again, I tried to doing as much in render as possible, but some of those light up type of stuff was just better to do in comp. So yeah, just looking attribute, and this thing itself is just some standard settings. I didn't do much different. It's the same in the boxes too, but they just have different materials assigned. I think all I did here was with the texture sampler, just the scale is different, so and rotate it a little bit. So that the displacement texture will be a little bit different on the two things. The particle material, pretty basic. You can see it has an emission input color and an alpha. So alpha will basically, so how am I doing it here? So I'm actually using the alpha as well to multiply. I guess I'm not using opacity, but it should evaluate to 1. So if they're less opaque, then I guess they would be they would emit less. So I'm using the length attribute. So again, it was from the length of the velocity, and what I'm using here. So the color. So again, how we used the color was if we go into the particles and have a look at what that's doing. So again, we had the point cloud lookup thing where we would, when they are like colored based on how close they are to the boxes. So that's with the length attribute. Didn't use that. Oh wait, no, that was from the color. So we did end up using it, but not in the shader. The multi-attribute, sometimes I just write this out to sort of as a multiplier for something. I'm not sure where I did that here. Let's see if it, so multi is just evaluating to 2. So I could have also just multiplied it in here by 2, but I think I intended to maybe do something with an attribute and didn't end up implementing that. But they're just writing out to the emission and so the emission color. So they will like glow with a nice like either a blue or orange color. So those are the particles, and the electricity is just incandescent material here with a illumination stuff applied. And the electricity was rendered separately with depth of field because it just looked better. And the entire thing, by the way, the entire thing was rendered with depth of field and motion blur. And the reason why I did that is just because particles don't look good, in my opinion, if you render them without depth of field and try doing it in post. It just looks so much better when you do it, like when you do it in actually in render, because like the small stuff here needs to be so high sampled in order to like do it properly in post, and then still the resolution for the small stuff is just not that great. Like you cannot see anything behind here, so it just looks so much better when you just render it in this case. And I was okay with taking the render hit for this. Don't remember exactly how long it took per frame. I think like 15 minutes or something. I could be wrong. I don't recall. But so how these were rendered is just usually I make render nodes and I call them rndr_, and then you can use in the AUVs you can use rndr_star, and it will render everything within the name, and it doesn't matter what is enabled. So global illumination, I only used primary with brute force. I used volumetric scattering and with a whole bunch of lights. So some have like more stuff going on and some have less stuff. And I used a little bokeh on the lens, so a custom bokeh that I made. So yeah, a custom bokeh that I made and just thought it looked pretty good. Yeah, and like in all of the lights, it's just like I'm not sure what to say about it. There's just lights everywhere. If I turn them all on, I just try to sort of art direct the light, like where it would be nice to have light shafts and other stuff. So there's like multiple over here that sort of overlap, but like one is like smaller and one is bigger. And you can get these nice little overlap type things. Yeah, then we can get these nice overlap stuff. Yeah, I just thought that looked pretty cool. So yeah, those are just the lights. So just basic Redshift lights. And again, the electricity was rendered separately and then comped on top. So if we have a look at that, I'm not sure where we did it. Let me see if I can find my electricity. So yeah, there we go. So this is our electricity, and I ended up tinting it a little bit orange, so that wasn't because the basic render wasn't was like more blue. You see I rendered it with like the depth of field, and just like it just looked a lot better. than trying to add that in, because again, with like stuff like this, so tiny, it just looks better when you do it, I guess, in render. And I ended up like there's still quite a bit of noise in this render, but I ended up denoising it a little bit. So yeah, that's basically the overview of the entire project, I think. The one thing that you still have here is electric displays. So when rendering the electricity, I just wanted the boxes to be black. So I just made a reflective sort of material, and I turned off all of the lights, so they would still reflect some of the. I can show you that. So they would still reflect some of the lights, but so I needed a separate material for that, which did also have the displacement, but just wouldn't do a lot of other stuff. So I need to put this on the boxes. Let's put it on. They need to have the same material, of course, as the run you used before, else the displacement won't line up. But right, so let's fire this up again. Okay, so I'm not sure why this is now. Okay, it still has one. Okay, like that. Let's reload. Yeah, and now you can see. So it will catch the light and give the nice reflections and light bouncing off from the details. And then we could just like, again, comp that on top. So it's not just the electricity, but it's also like some of the nice reflections and other stuff. So yeah, that was the entire project. One more thing, I guess, how I'm doing the focus is just vector length to origin. So that sets the focus to the look at. There's some wiggles going on based on motion effects. There's an overall displacement control, which does the displace, which I use motion effects for as well. Okay, so there's one more thing that I wanted to cover. It's the sample count. Now, I know normally with Redshift, you don't want to crank up the unified samples too much, and you prefer to do it in sampling override. So I did override the reflection sampling to get a little bit clearer reflections. But I did crank up the max samples in here because, of course, I was rendering depth of field and motion blur inside of the renderer, because, as I said before, it just gave a much better look to the overall image, having the particles like really interacting with the lens and having real depth of field. So yeah, that's that for the render settings. Apart from that, there's not really that much interesting going on. I mean, sampling overrides. When it comes to AOVs, just have all the default AOVs. So diffuse, reflection, refraction, GI, specular, Z depth. I did render it. As I said, I rendered the depth of field, but it can always be handy to add some extra like smoky stuff in comp. Yeah, crypto matte volume. So like a lot of the just a lot of the default materials, and yeah, it was slow to comp, but apparently in the new After Effects update, EXR support is finally a lot faster. Haven't tried that out that much, but gonna try that soon. So yeah, that was that. But yeah, that's basically it. So if you have any questions, please let me know. Again, if you want the project files, if you want the rigid body emission thing, be sure to subscribe on Patreon, and then you can download all of that stuff, all of the files, look through it. I'd love to see what you guys come up with like some of these techniques. It's been a long one, but a good one, I think. And well, I guess talk to you next time, hopefully. So I have a lot of cool stuff planned for next year as well. Planning to put more effort into Patreon to get more content out for you guys. So see you there, hopefully. Bye.